Director of NOAA's Virtual Lab, and we're here for another session of the VLabForum for the month of July 2018. I'm joined here in the VLabForum studios in beautiful downtown Silver Spring in the shadow of the giant acorn by a production manager, logistics guy, all-around wonderful person, John Chattel. We're about to embark on a really interesting talk. And before I go into that in a little bit, I want to remind everyone that the forum, the format of the VLabForum is that we do about 30 minutes of content, and the remainder of the hour is devoted to Q&A. So we ask that you think about questions that you might want to ask the speaker during the Q&A session, and use the raise your hand feature of the GoToWebinar to indicate that you would like to ask a question. We will unmute you so you can ask our speaker directly, or you can use the chat feature in order to submit a question that way, in which case we will relay your question to the speaker on your behalf. Also a reminder that these sessions are recorded for posterity up on YouTube, and the recording will be uploaded shortly after the conclusion of today's session, so you can share it with your colleagues, your friends, your pets even, if you like. Without further ado, we're privileged to have Dr. Diana Stovern, who is affiliated with CERES and WPC, the National Weather Service. Is going to provide us an update on the status of the Extreme Precipitation Forecast Improvement Project. And this continues in our series of late in the VLabForum, focusing on IDSS topics, since the Weather Service is moving increasingly in the direction of providing extensive impact-based decision support services. And what does that mean for our operations as it evolves to do so? So, without further ado, Diana, are you there?
Yes, I am.
All right. The floor is yours. The virtual floor is yours, so to speak.
All right. Thank you, Steve. Well, welcome, everybody. I am here on behalf of the project team to present our updates on an STI-funded program called the Extreme Precipitation Forecast Improvement Project. And as Steve said, I am Diana Stovern, and I'm a research meteorologist contracted by WPC to take the team's project ideas and integrate them into a set of operational tools. Steve, for some reason I'm having trouble switching. Oh, here we go. Sorry about that. The primary goal of these tools are to improve situational awareness and impact-based decision support services associated with extreme precipitation events. What our team does is leverage the current software and data sets that are already available to forecasters to help them identify when an extreme rainfall event is a threat, and to help them convey the extent of risk to their partners and the public. Now, there's plenty of motivation behind why this team was established. Not the least is because high-impact precipitation events, some of the leading causes of damage in the United States are because of flood events from precipitation. But there have also been many NWS service assessments that have highlighted deficiencies in how weather forecast offices and WPC communicate the full extent of risk of an event, and how they collaborate with each other in terms of a final message. And so on this screen here, I just have some quotes from 3 service assessments. One was from Southeast 2009, the Front Range 2013 event, and then the 2015 event. So before I get into the details, I would like to introduce you to the Extreme QPF Collaboration Team. We also call ourselves the Extreme Team for short. Our team includes meteorologists and hydrologists from all facets of NOAA that are directly impacted by this problem. So we are led by Jim Nelson, the Development and Training Branch Chief at the Weather Prediction Center. And we have science and operations officers from every region in the country. We have an RFC rep to represent their needs. And we also collaborate with hydrologists, meteorologists, and researchers in academia, as well as other scientific NOAA agencies, to try to solve this problem. So as I go through this presentation, I'm going to explain to you the R2O path we took to make our vision into reality. So first, the team had to do plenty of research on the topic, and that involved exploring the factors associated with severe flooding from rainfall, and that can be broken down into two aspects. One is the rainfall climatologically significant for that area, and number two are the antecedent conditions favorable for flooding. And by antecedent conditions, I mean things like soil moisture, terrain, and the existence of low water crossings, burn scars, etc. The team also consulted with experts on extreme precipitation, as I had previously mentioned. And they also considered a design concept and which data sources they wanted to leverage. So there's another tool that is maintained by WPC called the Ensemble Situational Awareness Table. And that the ESAT, for short, it showed proof that using climate data to highlight anomalous fields in the data helps to effectively raise awareness to forecasters to the potential for an extreme event. And so it was because of the ESAT that we had the idea for our tool that I'm going to present to you in this presentation, the Extreme Precipitation Forecast Table. So before I get too much into the details, I want to give you a little bit of a review on average recurrence intervals, or ARIs. First of all, an ARI is the average or expected amount of time, usually in years, between exceedances of rainfall over a given duration. When I'm talking about ARIs in this presentation, I am never referring to flooding ARIs. Rainfall ARIs do not necessarily represent a flooding ARI of the same magnitude. So I'm only thinking about rainfall in terms of precipitation in inches. The data source that we are leveraging is the NOAA Atlas 14 because it's the most recent comprehensive data set that provides the point-based estimates that we need to compare to QPS. And the power in ARIs is that they can be used to compare to observed or forecasted rainfall to measure the rarity or extreme nature of an event. And that makes it ideal for the impact-based decision support services. Now, at some point, I might be referring to a top 1%, that's the annual exceedance probability. An AEP is approximately the reciprocal of an ARI. And the AEP or ARI is considered extreme when you're thinking about events that are 100 years or above, or that have an AEP of 1% or below. So why else do we use ARIs for this project? Well, some people don't realize that besides for the fact that they can be used to convey rarity, they are used in the design of hydrologic structures and flood retention systems. Thus, the impact can be better assessed by NWS forecasters and their core partners when rainfall is expected to exceed these ARIs. So, for example, if you know that you have some culverts or drainage systems that are only designed to withstand rainfall of a 5-year ARI, you know that once that ARI is exceeded, that structure has the potential to break down. So again, back to the R2O pathway, what's the type of research that this team conducted before designing our tool? Well, we worked with some folks at Colorado State University, Dr. Russ Schumacher, and soon to be Dr. Greg Herman. And with all of Greg's work, he tried to correlate average recurrence intervals to flash flood reports. And he found that in general, ARIs of certain thresholds are better correlated with flash flood reports compared to fixed QPS thresholds. And then in this image that you see on the right here, the left column contains fixed thresholds, 2, 3, up to 8 inches. The right contains ARIs. The bottom and the bottom left of each panel contains the flash flood report that is associated with that ARI exceedance. So you can see with some of these larger numbers, 426, 416 with the 2-year and 5-year, that these flash flood reports are better correlated with these ARIs than their counterparts at fixed thresholds. Besides for working with some folks at CSU, we had some internal research. Some of our LMRSC colleagues, Scott Lincoln and Rochelle Thomason, they conducted their own study for LMRSC and found that the 2-year ARI could be used for a warning threshold for their area, and a 25-year ARI could indicate major flooding. And then finally, in the very beginning of this team's formation, Rich Grum, who was a former Sioux at State College, he was looking at the GFS to see how well it captures top 1% events. And he found that the GFS tends to under-forecast 6-hour QPF in particular. And so if you see a ratio of QPF to 100-year ARI that are over 70%, you should start to be concerned about the potential of an extreme event occurring. And then, of course, values near 100% are rare, and they are often indicative of extreme rainfall and higher end flooding event occurring. And this is a very important point to keep in mind as I explain to you the concept of the extreme precipitation forecast table. Now, onto the testing part of our R2O path. So we chose our design. We wanted to do a situational awareness table to highlight the climatologically significant rainfall. We're leveraging the NOAA Atlas 14 database of ARIs. And when it came to the platform, we decided to choose AWIPS because AWIPS is used by the weather forecast offices, river forecast centers, and WPC and regional headquarters. And all of them contain a large suite of QPF guidance. So from there, this is a sample of the table that we produced. On the left-hand part of the table is where all of the model guidance is. Time increases from left to right, and then it contains all these chiclets, which represent the grids that come from these models. Now, the value in each grid is the maximum QPF to 100-year ARI ratio found in that grid. It takes the max and it plunks it in this box so the forecaster can click on the box and investigate where those values are located. Before I continue talking about EPFT, I want to mention the ARI data that's in AWIPS. Now, when ARIs were first baselined in AWIPS, they were only available in D2D and SSMP. Our team developed an installation package that you can get on the VLab that utilizes the data in GFE, the graphical forecast editor, because the GFE is where you would run the EPFT. Note that the data, the NOAA Atlas 14, does not exist yet for the entire U.S. Texas is expected to be completed in this year, 2018, but the Pacific, Northwest, and some of the Northwest states, they do not have a start or end date. But working with Russ and Greg at CSU, they provided us with an extra data set called the NOAA 14 All-US V2 that has stitched in data from older ARI data sets. And that's the Text Paper 40 and NOAA Atlas 2. And this data set, the NOAA 14 All-US V2, is also available for AWIPS, and you can get that on the VLab. And there we have ARIs from 1 up to 100 years. And so all the tools that I'm showing you today can use both the NOAA 14 Atlas and NOAA 14 All-US V2 to run them. So that means no matter where you are in the continental United States, you can use any of the tools that I'm showing you today. Okay, so first designing this table, I gave it to the team members, all of our SUs, and John Zeitler from EWX had a really good breakdown on how the tool can be used for a potential high-impact event. And really, John summarized it as a one-stop shop tool to check for rarity and consistency and all the guidance you receive in AWIPS. But of course, since antecedent conditions are not considered, you should overlay the data with low water crossings and burn scars, areas of high stream flow, et cetera, to highlight trouble areas. And then you can create IDSS graphics that highlight the extreme nature of the event and your confidence. So based off of John's feedback and my other team members' feedback, we calibrated the table, changed up the color table associated with it, and this key right here is what we came up with as generally a rough user guide that forecasters can use to assess the results of the table. Okay, so in its current form, here is the extreme precipitation forecast table. I do have these websites in the VLab where you can get the ARI info package in the tool, but also have this at the very end of the show as well. And again, just to overview, the EPFT takes any piece of QPF guidance available in GFE, finds the maximum ratio of QPF to ARI, and displays the value in the table. And then just like the ESAT, it's designed so you can click on a cell of interest, and the grid of percentages is brought up in the spatial editor in GFE, so then you can go and locate where that cell is located in the map. So besides for the EPFT, we have two other tables that we introduced just based on feedback from the field and what other forecasters would like to see. The average recurrence interval table, which I will sometimes call the ARIT, is a very similar concept to the EPFT, but it shows the maximum recurrence interval in the table rather than showing how close the guidance is to a specific ARI threshold. We also have the extreme precipitation assessment table, almost identical to the EPFT, except for instead of comparing to QPF, is comparing to observed precipitation, so QPE. This is something that the forecaster can look at after the event has occurred so they can see how climatologically significant the observed rainfall was. Okay, so I want to demonstrate the latest version of the EPFT, version 2.0, from a March atmospheric river event that occurred this year on the West Coast. What was particularly concerning about this event is that there was potential for heavy rain to fall on burn scars from the record-breaking fire season that had occurred earlier in the season in California. Now, a lot of people know that are familiar in this field that it does not take much rain on a burn scar to produce flooding, but the more climatologically significant rainfall you have, the more potential there is for catastrophic damage. Now, as I go through this demonstration, I'm going to use a top-down approach to analyzing, or in other words, mining the guidance as if I were a forecaster at the Weather Prediction Center trying to assess the situation for the West. Now, I ran the EPFT on Monday, March 19th with the default configuration. That's what you see here in front of you. The default configuration is for 6-hour durations, and it compares to the 100-year ARI. And I ran it over an edit area for the whole entire western U.S. And what I can already see is that the models show good agreement that a rain event will occur and there is some potential to produce significant rainfall, especially in some of the global models, like this 97% associated with the ECMWF and the 99% associated with the GFS. That makes me want to investigate those areas a little bit more to see what really is the potential for an extreme event. Now, being that atmospheric rivers are usually larger scale multi-day events, longer duration rainfall tends to be more significant. So switching to the 24-hour duration will cause the table to light up more as opposed to shorter durations. And you can see that here in this image because now we have more models that are actually exceeding a 100-year event and more models that are actually starting to near with values over 70% of the ARI. And then with the higher durations, you can start to see which models and how many models are producing a certain threshold of ARI. The next step that I would take as a forecaster is reducing the EPFT to look at a specific edit area where extreme rainfall amounts or near extreme rainfall amounts are consistently occurring. So in this next image, I have ran the table to view the results just over the CWA HNX, that's the San Joaquin Valley Hanford office. The area over the CWA is pretty expansive with significant rainfall. And at this point, if the forecaster wanted to see which threshold is being consistently exceeded by the model, they can continue to reduce it from the 100-year ARI to the 25-year ARI. And while clicking on the cells and looking at the images, they can finally get to a point where you can see here where during this time period, the 22nd to the 23rd, the majority of models are indicating that the 10-year ARI will be exceeded somewhere in the CWA for this time period. Now, another function that forecasters have to do more data mining is there is a little pop-up that they can show the ARI, the QPF, or a function called contour ARI, which actually contours the QPF in the context of each average recurrence interval. So this image right here comes from the ECMWF, and each color represents an ARI that would be exceeded. And of course, the point of this is the forecaster can get a sense of how widespread the significant rainfall is. Now, if I were a forecaster at WPC and seeing this, I might consider getting onto the NWS chat or getting HNX a call just to see if they need any assistance with the meteorological ingredients and with the risk assessment as the forecasters at this office start to think about what their message is going to be and the DSS. Now, after the event has taken place, the forecaster can go in and run the extreme precipitation assessment table to see how climatologically significant the rain event actually was. So here I have the EPAT example. The chiclets are associated, this 113 is associated with 18 to 0Z on the 21st, and this 111 associated with 0 to 60 on the 22nd. Since it's over such a large area that I ran the table, this 111 you can't even see in California. But this 113, this is showing that the ARI or the QPF was exceeded, I'm sorry, the 2-year ARI was exceeded by the QPF by 113%. Now, the point of having this, using the EPAT and using it regularly is that it will help the forecaster garner a sense of when a specific ARI event has occurred, they can associate those impacts with future ARI events in the future. Okay, so since we released the tool, the EPST, in 2016, we have made some improvements. First of all, we added WPC's probabilistic QPF. The PQPF feature can be used by forecasters and hydrologists to determine the probability of a climatologically significant or extreme rainfall occurring at a given location. And also, they can be used to identify where model guidance exists in the spread of probabilities assessed by WPC. At the end of the week, I will be uploading the new and improved ARIT, average recurrence interval table, to the VLab. Again, the ARIT, it was not previously configured to be used in the northwest of Texas, but now it can be used everywhere all across the United States, whether or not you're at an RFC, FO, headquarters, or WPC. And I made the startup GUI a little bit more user-friendly by separating the convective allowing models from some of the larger scale global models. And here you can choose whatever CAMs you're interested in and a shorter duration period so you can assess the potential for extreme rainfall from convective systems. Now, we always have improvements in the works for these particular tools. One thing that I have included into the EPST is the addition of flash flood guidance. And one of my RFC team members, Emily, has provided an example at her office of what this new tool looks like. And essentially, all that it does is once the flash flood guidance is exceeded at the same point as the maximum QPF to ARI ratio, it shows an asterisk next to that number. And then the forecaster can click on asterisk and bring up a grid of bring up a difference grid of the FFG and QPS. And what our goal with this tool is we wanted to consolidate as much information as possible into one tool so forecasters don't have to use a large suite of tools to get all of this information. And then in the future, we are still planning on adding longer duration ARIs to the data set and probability of ARI exceedances. And perhaps a future project, we want to have another situational awareness table that we include other anomalous meteorological ingredients, such as precipitable water. And I'm also designing a table that is more geared towards short-term precipitation / flood-producing situations. So it'll be focused on the 24-hour period. We have a couple of web-based products that have developed over the past year from our team's ideas. The Extreme Precipitation Monitor is now available on WPC's webpage, and that displays the climatological significance of rainfall forecasted by WPC. And it is generated by WPC's day 1 to 3 QPS, and you can view it for the 6 or 24-hour periods. And each contour level represents the ARI or AEP equivalent of QPS expected to be equal or exceeded during a specific time period. And then finally, this is a new development. I'm working with Bill Lamberson at WPC to get the EPFT web-based and as a part of the ESAT suite. And so this is just a sample of what Bill is doing. Same thing that we have in AWIPS, where you can see the maximum ratio of QPS to the 100-year ARI. Click on the chiclet, and then you'll be able to view the results in the map up on the screen. So with all the successes that we've had with this team with introducing the tools and the training, we are still aware that there are many challenges moving forward. First of all, ARIs are still widely misunderstood by the public. So I think that what our team would like to focus on is more training when it comes to our forecasters, so the forecasters can maybe help those in the public that are not familiar with ARIs get a better handle on the definition. And something that I've heard just from the forecasters in the field is they'd like to see more research that link specific ARIs to specific impacts. Like what you saw with Rochelle Thomason's work, they were able to associate a 2-year with the warning threshold, but that's just for LMRFC. If we can get more projects like that going on for the rest of the United States, I think that it would be very powerful to basically optimize ARIs as a situational awareness tool. Speaking of training, there are 3 modules out there that you can take to familiarize yourself with ARIs and the Extreme Precipitation Forecast Table. I did this with Jill Hardy at WDTV. And with that, I would like to say thank you to everybody who listened in. Here are the websites on the VLab FTP where you can download the data and various tools. And then beneath that, I have all of our regional representatives and their emails in case you want to ask them any questions or need any help with the installation. And of course, I'm always available for questions and any help with installation as well. And so with that, I will take questions.
Thank you so much, Diana. Really impressive presentation, tremendous amount of work that's gone into this, and you really dove in and gave us a wonderful overview. So let me remind everyone that now we're into the Q&A, and we invite people to raise their hands in the GoToWebinar feature to ask a question directly to Diana. And at this point, so I see one, Ken Johnson. You want to unmute, Ken? Ken, you there?
Yes, I am. Hi, Diana. This is Ken Johnson, Eastern Region SSD. I've got a couple questions. The first one, maybe you can clear something up for me. In the beginning of the presentation, you mentioned you didn't want to link rainfall ARIs to flooding ARIs. However, when you close the presentation here, you were talking about linking ARIs to impacts. Is there a contradiction there, or is it just the way we're using flooding? Is flooding considered an impact, or, you know, could you clear up my confusion there?
Yes, I can try to clarify that. So first of all, with the slide that you're referring to, and hopefully I can get back to it easily here. I did not want to, well, let me go back here. Okay, here it is. I do not want to relate the two because they're two different metrics in which they're measured. Rainfall ARIs are measured in terms of inches of rainfall. Flooding ARIs are measured in terms of stream flow height, usually in feet. However, there does seem to be some implication in relating ARIs of specific rainfall to potential flood impacts, not necessarily stream flow height, but the impacts that can be caused from flooding. And the reason for that is because of the point that I bring up, that these hydrologic structures and flood retention systems are designed based off of precipitation ARIs. Now, it's a lot more complicated than how I'm trying to simplify it here, but essentially a civil engineer would take the precipitation ARI, they would put it in their model, and they would get a flooding ARI out of it, and then that's how they would design their structure. If I'm saying any of this correctly, then anybody can chime in and correct me. But that's why we know there is some implication of relating preset ARIs to impact, and it's because of this fact here that since they're used in the design of hydrologic structures, you should be able to see some impacts.
Okay, appreciate that. I think I see what you mean. Thank you.
Okay.
The second question is this now considered to be operational?
Yes.
And
Yes.
If so, what process did you go through to hand it off from a research to an operational to be supported in terms of operations and maintenance?
Well, that is a good question, and believe it or not, this national SULED team was kind of the first of its kind when it was developed in 2015, and so we were kind of in uncharted territory. But the way that we did it is we worked with the Office of Science and Technology Integration and WPC to design this tool. We worked with some folks at WCTV to get the training out on this tool, and then what we did is after I designed the tool and submitted the training, I uploaded it to the VLab. But right now, in terms of maintenance, I am the only one who is maintaining and developing the tool with the help of my forecasters and hydrologists on my team that give me feedback. Now, it is not a baseline tool, so it's not something that NCF maintains. So any updates that are on here are strictly done by me. But we do envision getting this tool baseline somewhere in the near future, because then it would help offices that when they do get a new AWIPS build, sometimes the tool does break. That's just the nature of an AWIPS build. But we're hoping that by getting this tool baselined, which I know is a rigorous process, that those kind of problems would be mitigated.
Okay, well, thank you, and a really nice presentation. Thank you.
Okay, thank you.
Okay, thanks, Ken. Others, please use the raise your hand feature if you'd like to ask a question, or chat it into the chat box. Following up on Ken, Diana, so is this a local app in AWIPS parlance, basically?
Yes, yes, it would technically be considered a local app that you would have to install locally at your office.
Okay, so is it the code is in the VLab, but it's actually in the software collaboration portal piece of it?
Correct, correct. Yeah, it's
okay,
there with
great.
And installation instructions.
Right. Okay. So following up on the use of VLab for obvious reasons, so one of the use cases that we found very effective for development of new tools and getting them evaluated and connecting developers like yourself with the users, forecasters, is establishing a community in the VLab which has like an email forum. So this is being used extensively for a number of projects like the National Blend of Models and the RTMA, and I'm forgetting some already. So is that something that you have, or you might like to do. In other words, users in the field of your tool say they post something to this forum, you're monitoring it, or your team is monitoring it, and then they say, oh, this worked great here, or something went wrong, and then you investigate that sort of thing. Is that something that you have or are considering?
Yes, and I am the one that gets all those emails and do the development and the fixes. And actually, we had someone a few weeks ago that requested an enhancement to the EPAT, and I just uploaded a new EPAT to the VLab based off of her comments. And so I am looking at them every day, and I take everybody's comments and I try to enhance the tools to the best of my ability. But I have to make sure that those enhancements can be applied across the whole United States. So I just, I hope that people keep that in mind when they request some of these things. But yes, I'm monitoring it every day and fixing it based off of people's feedback.
Okay, so there's a Extreme Precipitation Project community that's in there where that's happening?
I don't know if it's associated with the Extreme Precipitation Project community, but it is associated with the specific tools themselves. So if people have a problem with the EFT, they can go into the SCP VLabForum and then I guess set up a trouble ticket, I guess what it would be, that would get used. But I'm not sure that it's part of the Extreme Precipitation Forecast Improvement Project. That is something that we can consider doing if you think that it would be helpful.
Yeah, we can take it offline to see, to dive down a little bit more deeply. I mean, if what you're doing is meeting your needs, then that's fine. I'm going to pause now. I got other questions, but I want to go. Jason Engel has asked to be unmuted, so go ahead, Jason.
Yes, can you hear me?
Yep, go ahead.
Yeah, my question is regarding the ARIT and the EPATs. My original understanding until this webinar was that they were accessible within the same table, and so you have to go to the collaboration software table in VLab and upload. You have to upload that. That's a separate installation package.
Yes.
But
it's difficult to install these. I mean, because they're separate procedures. Once you have installed the ARI data, that's the hardest part of this whole thing. Otherwise, the EPFT, ARIT, and EPAT, they're all GFE procedures where it's as simple as copy and pasting the contents of the script into the procedure in GFE to be able to run it.
Okay, so it's just like EPFT. They're separate procedures that we would set up. Okay, that's what I want. That was my question. All right, thank you.
Yep.
Thank you, Jason. Okay, so this is Steve again. Diana, I had a question about, so there's a list, this is not meant to be critical, but this is for myself being a novice or just looking at this. I think it's the second time I've seen you give a presentation. It's kind of a fire hose. There's a lot of information. So, I mean, I'm not clear. Could you kind of, I hate to use this term, but like concept of operations for this, WPC is doing something, and then the local offices are installing these local apps to look at the data, and then they're supposed to be working with their core partners on IDSS. And can you like walk us through how you think this is supposed to work?
Well, I mean, it's just meant to be a situational awareness tool that, because it's on AWIPS, it's on the same platform that all of these agencies can use. So, for example, if someone's looking at the results of the EPAT, they would have their forecast, or sorry, not the EPAT, but the EPFT. They would have their forecast in there. They could look at WPC guidance. They could look at RSC, QPF, and look at their neighbors through intersite coordination mode to basically see how their forecast compares to other forecasts in just in a very easy table that helps to display the climatological significance. And that was the whole point here, is to create a situational awareness table that can be used across the board by all these operational entities. In terms of how it would be used for DSS, that's probably the weakest point that we have here, is because the ARIs, or the NOAA 14, is such a new data set. There has not been a lot of work with the ARIs. It's just starting to take off in the National Weather Service. So in terms of how it's used for DSS, you can use the table to maybe assess the risk and how many models are in agreement and how much in agreement you are with your fellow agencies. But otherwise, we want the DSS to be focused with the local offices, because they're the ones that have the expertise and have knowledge of like the local topography and the local weather system to really help with that decision support.
Okay. Yeah. So that makes sense. And this gets back to the idea of sharing information about how different people are using this set of tools to support IDSS, et cetera, and sharing best practices, I guess. A quick question I got is on the information you provided about the culverts and this information that engineers use in designing these things on the precipitation ARIs. Is could a forecast office access a database for the various culverts in their CWA and get the information about the design specs, and then based on this information provide IDSS like, oh, this culvert or this retention pond is going to blow because of what we expect to happen? Or is that information like buried in somebody's engineering blueprints and it's almost impossible to get?
So I have a feeling that information is buried, but I know that there are other efforts within NOAA to get more of that data, especially GIS-based data, into AWIPS, so forecasters can have that capability. Now, our team is not working on that, but I know that it is something that's high in demand from the field to be able to see where there are, specific culverts, specific dams, what their ARI threshold is, and whether or not they are potential trouble areas. Like if you have a newer dam, it's going to be more robust. If you have an older dam, there's more of a chance for it to break down. No, that is not in AWIPS as far as I know, but I'm sure if enough people speak up about it, we can get some of that information in the AWIPS in the future.
Okay, thanks. Jason we're going to unmute Jason again. You have a follow-up question, Jason? No? Okay, we'll mute him back out. I saw Craig Schmidt had his hand up, but then he put it down. It doesn't look like he has. Does he have a speaker? Does he have a... oh, there he is. Okay, we're going to unmute Craig. And there we go, Craig. Go ahead.
Can you hear me? You guys hear me okay?
We can, Craig. Go ahead.
Right. Excellent. Yeah, I was just, at the time, I was going to help answer your original question about how it's being used. We've been using this now, this tool for starting last year and through this year. And it's just kind of a situational awareness tool and gets us to focus in on when we might have some issues in the future. And as she mentioned, how many models are kind of starting to agree on whether we're looking at a potential minor event, potential moderate, potential major rainfall event, and then just kind of using that information to help us focus our messaging on how severe an event might be in the future. So that's kind of one of the ways we're using it. We're actually watching it rather intently for tomorrow around here, as a matter of fact. And then as far as you also mentioned those ARIs and whether they're available, we have worked a little bit with our state Department of Transportation. Some of the regions have a lot of this data for the culverts and different bridges around the state. So we've been trying to collect some of that and work with them to get that information, and then just, again, help us be better aware of where the trouble spots might be. We aren't necessarily going to be issuing specific products for something or anything like that, but at least knowing where the trouble spots might be will help us in our warnings and our messaging.
Well, thanks, Craig. That's really informative. Exactly the type of information I was looking to hear. Following up on that, so this thing could be lighting up like a Christmas tree so do you find that it's, how do you know when it's above the noise and you got to get serious about it?
For me, it's just been kind of watching it over a period of time and getting a feel for it.
So you're doing like your own kind of calibration?
Yeah, kind of. The ARIs are just one tool. You know, we use it in conjunction. You know, this again, it helps us focus on where in the 2 to 5 day period we should be focusing on for a heavy rain event. And then as we get closer to the event, then of course you start using your flash type information and your unit stream flows and that sort of thing to help you focus in on your warnings and that sort of thing. But this will help us I'd say more in terms of messaging the potential for an event in the, say, day 2 through 5 time period.
Right, and that's exactly how we intended this tool to be used. So I'm really happy to hear that.
Yeah, and so Craig, I mean, have you then gone out specifically and started that messaging 2 to 3 days ahead with your core partners?
Yeah, now we're not like going out and saying we're looking at a potential 100-year. We're not saying anything like that. We're just using it to help us express our confidence in the type of threat that we have coming up in a much more general sense than, you know, we're not throwing any of those numbers around. That's for sure.
Right. I totally understand that.
Sure.
It's kind of, but you are beginning to do some messaging. Yes. That's informed by this tool.
Yes,
right?
That's correct. That is correct. Yes. Yes.
Okay. Well, that's really cool.
For us, a lot of it would be the type of message that we're sending out to our emergency management list, to our hydro list, that sort of thing, of different partners that are interested in this information.
Fantastic. Okay, Craig, I'm going to switch now to David Welch. We're going to unmute David. He's got his hand raised. Can we get him? We need to send him a pin, right? David, we sent you an audio pin. You got to use that pin and for us to unmute you. If you can, or use the chat box. If you can't get the audio to work, and type your question in, and we will we'll relay it. While we're waiting for David, so I was going to ask Diana, what happened with Harvey? I'm sure you looked at Harvey.
Oh, I definitely looked at Harvey. Harvey was a really interesting case because I found that when people were assessing like how well the models did after the fact, that the model verification and how well they did was really dependent on how you were analyzing the storm itself. So, for example, with the Weather Prediction Center, they were looking at the models and how well they captured in their own forecast, the outline of the 2 inches outline of that event, which they did really well in. But in terms of the forecasting, the magnitude, the 50 inches, well, of course, that was unprecedented. That is something very hard to forecast. The global models did not do that well according to the EPFT. The EPFT still let up, but what I was surprised to see was how heavy the rain was according to the NAM, because for a few days leading up to that event, the NAM was indicating that a pretty widespread 100-year event would occur. And I just want to remind everybody that we max out at 100, even though we have the data to express in terms of a 500 or a 1,000-year event. We don't use those because those ARIs are highly extrapolated. But nevertheless, it was for a few days leading up to the event, the NAM and then the global model started catching on that this would be a widespread 100-plus-year event. And that was a really interesting case for me to look at the EPFT and review.
And I'm sure you're going to be presenting those results at a conference coming soon, maybe? Or maybe you already have.
Yeah, it was actually at the AMS annual this year that I presented some results on Harvey.
Okay. Right. Did we get from David? Oh, this is, okay, we've got, it actually says Emily. Instead of David Welch, could you scroll up, John? This is, oops. Hang on. We just lost the chat. There it is. This is Emily. I was going to say how the Lower Mississippi River Forecast Center uses it. You don't have to call on me. Okay. So Emily, I'm not sure.
From LMRC.
Hi, Diana. It's Emily. I had to use David's link to log in.
Yeah.
Go ahead, Emily.
I think it was Jason, but other people were asking questions on how to use it, so I appreciate Craig explaining how he uses it. I agree with Craig that this is very much a situational awareness tool, and being at an RFC, we actually have kind of a unique situation that we have such a large GeoPhy domain that we can see many events instead of just a WFO-centric one. And so someone was asking, how do you know how to use, what ARIs to use at what time? And I'll just say, like Craig said, that you have to learn how your area does it. And especially like with us, I have mountains that have flashiness in 3 to 6 hours. And then I have the tropics along the Gulf Coast where we can get 20 inches of rain and we barely get a blip. So it's a lot of just knowing your area and watching it and knowing how things respond. We use this a lot, especially in the 1 to 3 day range, to figure out where we need to focus for forecasting, but also for staffing. If we're going to have a long-range, widespread flood event over much of our area, we can kind of ramp up staffing using this and have more confidence in what's going to happen.
Fantastic, Emily. Really appreciate that, adding to the conversation about how it's being used. We got Patrick Burke, who has his hand raised. We're going to unmute him. Go ahead, Patrick.
Yeah, hi, Stephen. Hi, Diana. I'm actually working the WPC QPF desk today. So I just wanted to chime in to the fact that we use this also to inform the excessive rainfall outlooks. And I think we use it in much the same way as Craig was describing. It's just another confidence booster when you see the tool light up. But I did want to point out that it's really important to remember the scale of the event you're talking about and then which guidance you're looking at in particular. We find here at WPC and using this across the country, it's really the large scale, the large mesoscale or the synoptic events where the tool tends to be more useful, and a Hurricane Harvey would be included in that because it was high confidence and there was good clustering of models. So, yeah, for instance, on the other end of the spectrum, the monsoonal convection in the southwest, well, the Nam-Conus nest is going to spit out 8 or 9 inches of rain in some tiny spot and give you a 100-year flood just about every forecast cycle. But it's not particularly useful in that sense because we don't know exactly which little plot of land is going to receive that rainfall if it does occur. So the large scale events, and then I wanted to point out too that the WPC QPF itself tends to be on the conservative side because we're serving, in addition to everyone else, is serving particularly the river forecast centers and their hydrologic modeling efforts. So we will make an attempt to not go overboard in terms of the volume of water that we're forecasting. So when you see the WPC forecast start hitting some ARIs, then you've really got something there. I mean, the models will do it more frequently, but if the WPC forecast, which it did in Harvey, I think we were forecasting, I don't know, Diana, if it was a 50-year or 100-year right over Houston that night, but when you see that, that should really sound the alarm.
Thank you, Patrick. That's a really good point.
Yeah, I really appreciate you chiming in there, Patrick, because that information was not known by me. It's good to know that, you know, WP's mission dictates how you treat that, and so interpreting, you know, if you're going to use a alarm bells, it's when you guys start hitting these ARIs in the big numbers, then we know it's that we can account for that conservative approach. We've got, thank you, Patrick. So we got a writing question from Jason Engel. Diana, I'll read it to you. Is there a way to archive the EPFT data being implemented or being worked on? In other words, if a meteorologist is off but wants to know what the EPFT was showing, can it be accessed after the fact, stored? That's the question.
We've been looking into ways where you can store. It's really hard to do that from GFE, and from what I've gathered, it's not trivial. But now that we have a web-based version that's being developed, I think it will be a lot easier to try to archive the results. But I know that what we're doing at this point is if we want to see the results of the EPF team, we're not here, then I would call in to one of my colleagues at WFO Boulder. I'll have them run it and take a screenshot. But otherwise, I mean, that's the best that we have here for archiving images and collecting images. On the other hand, we have been looking into running the EPFT on a cron, so that the results are readily available every day for the forecaster to look at, especially if there's a 100-year event. But I'm not sure how to archive the EPFT even from a cron. Since it is something, though, that many forecasters have asked for across the U.S., I think that I'll have my team look into it a little bit more about archiving these images, because it would definitely help the goals of our team as well to be able to archive them.
Right, and Jason adds that this would help in learning the ARIs for a particular forecast area. And
right.
being able to do
Well,
that.
and then one of the things that I was looking into, this was a year ago now, was trying to get an example of the EPFT on the WESS, the Weather Event Simulator. I was working with someone at WVTV, so I think even getting the EPFT on the WESS would be very useful to help train and to give forecasters a better sense of how to use the EPFT in operations.
Okay. I got a follow-up question on the web page thing. So basically this can be manifested, or will be through a web page interface as well as the AWIPS local apps. Is that what you're shooting for?
Correct. There will be less data available on the web page because we just can't, get all the data that the local offices receive. But yes, in terms of what will be on the web page, it will be very similar, and you'll be able to see the results from some of the bigger name global models, the GFS, the ECMWF, the Canadian, and then of course some of the higher res models. We want to get the some more cams in there, like from the WRF ARW, the RAP, the HER, etc. So we will have a lot of the same models, but maybe not quite as large of a suite of guidance as you would get at a FO, which is probably a good thing. That the public like get to this page as well, and so we don't want to like overflow them with data. We just want to get the main models on there.
Okay, right. So one question in the room was when are you targeting to get the web page done?
Well, we're pretty far along with this prototype, but in terms of to get something at least in the experimental stage. I'm hoping that we can do it by the end of winter. That's my best guess.
Okay. And did you say you're intending to make this public?
Yes. First, it has to go, through the formal channels. It's going to be an experimental product, and then eventually, after we get the go-ahead, it will be made into a public product that you will be able to view through WPC's webpage.
Okay, and just, I'm curious to the thinking on making it public so that, just more people could benefit from it, or what was because, potentially it could be very, very popular if you get a ton of hits. I guess the one value specifically is that you could use, Google Analytics to see how many hits you get, how many as a way of checking the value. But anyway, could you elaborate a little bit more on your thoughts on making it public?
Yeah, so I don't expect that a lot of the layman's people in the public, like if you don't have knowledge of complex meteorology or hydrology, you probably would not be looking at this web page. Some emergency managers do have experience with using ARIs. And so this is the type of product that they would get use out of. Meteorologists and researchers that are not a part of the government, that don't have access to AWIPS, that do it for their own personal forecasting, they would get use out of it. But in terms of, just regular Joe Schmo on the street, we don't expect that he would be using this table just because ARIs are still widely understood by the public as it is. You do need to have some sort of atmospheric science background, even if it's just bit to be able to understand the results on the web page.
Okay. And with that, thank you, Diana. Go ahead.
Sorry.
No, finish what you're saying.
Oh, I was just going to say, so in that sense, the audience that would be viewing it are those that already are familiar, have some familiarity with ARIs.
Okay, great. So with that, we're going to have to wrap it up. I want to thank Diana for a really informative talk. I want to thank the participants for asking really great questions that helped give us all a better understanding of how this really cool and powerful tool is being used now. And it looks really exciting what's coming up. I think Ming-Ji would be really pleased to see this SDNI funded thing coming to great fruition for the benefit of Weather Service and NOAA. So a reminder that for those you want to share who weren't able to attend in person, that we'll be uploading the recording to the VLabForum website shortly after the end of the call here. Want to remind you that coming up in August, in September, in August, our talk on August 15th, we have Dr. Jeanette Sutton on social media communication across the weather continuum, introducing the social media engagement model for the Weather Service, another IDSS flavored talk. And in September, Dr. Joe Rittberger will be presenting baseline measures of reception, comprehension, and response to severe weather forecasts and warnings. Another really cool talk on looking at IDSS and social science applications relevant to it. So again, thank you, Diana, and we will be signing off momentarily.
Thank you, Steve. Thank you, everybody.
All righty. Bye-bye.